This session, we are going to discuss about congruence modulo n or introduction to congruence. So we'll discuss the definition. Let n be any fixed integer and a and b or any two integers. In definition, we will denote a is congruent to b in mod n. So this is the notation of congruence modulo n, the two integers a and b, we will write a is congruent to b in mod n if n divides a minus b, or a minus b can be written as n into k for any k, for any integer, say k. That is, n divides here, the fixed integer n divides a minus b, or a minus b can be written as a multiple of n. So maybe k may be 0, 1, 2, 3, etc. It belongs to integer, maybe positive or negative. Here also a minus b, we may get positive number or negative number. So usually in another way, if I divide a by n, whatever the remainder we will get, that is nothing but b. Usually b is less than n. Sometimes while solving the problem, if we may get the value of b is more, then we will divide n, and what is the remainder, divide b by n, and what is the remainder, that remainder you can enter. Example, we will discuss the example. 31 is congruent to 3 in mod 7. So that is, according to this definition, n divides a minus b, 7 divides 31 minus 3, that is 7 divides 28, or 28 can be written as, so some number multiplied by 7, that is 7 fours are 28. Similarly, another example, if I take minus 31 is congruent to 4 in mod 7. That is 7 divides minus 31 minus 4, or 7 divides minus 35. Nothing but 35 can be written as, minus 35 can be written as minus 35 is equal to some number multiplied by 7. So what is that number, is minus 5. So 7 into minus 5 is minus 35. So we may get positive or negative number. So this is the congruent modulo n. For some example, for example 25 is congruent to 12 in mod 7. So just we check, is 7 divides 25 minus 12. If it is not, then we will say it is not congruent or incongruent. So it is a generalized word, incongruent. 7 does not divide 25 minus 12. Now we will solve simple problems to understand this congruence modulo n. Now let me take one problem. We have to find the least positive value of x. So for this simple problem, we will take 71 is congruent to x in mod 8. So we have to calculate the value of x such that 71 is congruent to 8 in mod 8. So as in the definition I told, if you divide 71 by 8, what is the remainder we will get? That remainder. So if a is congruent to b in mod n, by the definition, n divides a minus b, or a minus b can be written as multiple of n. That is one way. Another way is, if you divide the number a by n, okay, whatever the remainder we will get, that is nothing but b. Okay, so just if we divide this 71 and that is by 8, so you will get 8 is 64, and the remainder gives 7. So that is 71 is congruent to 7 in mod 8. So that is the value of x equals 7. This is one simple example. Let me take another example. 78 plus x is congruent to 3 in mod 5. Now here, by definition, A is congruent to B in mod n. So implies A minus B can be written as n into k, that is multiple of n, that is a minus b can be written as multiple of n. So our n divides a minus b. By this definition, what happens our problem? 78 plus x minus 3 is a multiple of 5, that is 5 into some number, some integers 1 2 3 4 like that. Our 78 minus 3 is 75 plus x is equal to 5 into k. So how to calculate the value of x such that LHS is equal to RHS for different values of k. So nothing but just we understand RHS is a multiple of 5, nothing but 5, 10, 15 like that. So LHS, some number, it is divisible by 5. This way we have to think. So for example, directly if I divide 75 by 5, what we will get 5 15s, okay, sorry, yeah, 5 15s 75, but the remainder gives here 0. So 0, what we are going to calculate in this problem is we have to find the least positive integer. So here 0 is not a least positive integer. 0 we call it as non-negative. So the next number we have to search, that is by trial and error method. Give the values to the x such that 1, 2, 3, 4 such that it is the LHS. Whatever the sum, it is divisible by 5. So if I put 1, you will get 76. 2 means 77, like that. It is not divisible by 5. So the least positive value of x is 5. If I put x is equal to 5, then gives it is 80. 80 is divisible by 5. So in this way, by trial and error method, we can calculate the value of x. So one more example if I take, that is 89 is congruent to x plus 3, x plus 3 in mod 4. So again, by definition, this can be written as 89 minus of x plus 3 is a multiple of 4, that is 4 times k. So that is 89 minus x minus 3 is equal to 4 times k, or 89 minus 3, that is 86. 86 minus x is equal to 4 times k. Now divide 86 by 4. So we will get 21s are 4 2s are 8. 4 2s are 8. This becomes 0. You take 6. 4 1s are 4. And the remainder is 2. Now for the least value of x is 2. So for x is equal to 2, what we will get here 84. 84 is a divisible by 4. So therefore, in this congruence modulo n, mainly we will concentrate the value, that is the remainder gives the value of x. The next session we will solve some more problems, simple problems depending on this congruence modulo n.